All right, hey everyone. So I think we're live now. Welcome to our workshop. First of all, my name is Henry, and I lead the DevRel team for APAC for Sway Net Network. And for our workshop today, we have James, the co-founder of Shinami, and the topic that we'll be covering today is going to be how to do gasless sponsored transactions on site. And James, feel free to start.
All right, thank you, Henry. Hi, everyone. Thanks for joining. So you said, my name is James. I'm one of the co-founders of Shinami. Today, I'm going to be going over one of our newest features, which is the gas station. So the agenda of this talk, I'm going to give sort of an introduction into Shinami, kind of some of the other services that we offer and how they feed into gas station. I'll go into the specifics of the gas station, and then we'll actually do a live demo on Testnet with the gas station. At the end, I'll leave some time for some questions. All right, so let's get started. So the first offering that we have from Shinami is the Sui node service, and this is the easiest way to read and write to the Sui blockchain. For the Sui blockchain, so there you have a few options if you want to interact with that blockchain. So I'll go through a few of these options. So the first one is self-hosted, and so in this scenario, you would basically use like a cloud provider like AWS or GCP. You could even buy your own physical machines if you wanted to. From there, you would have to load the Sui blockchain client onto these machines, sync it up, make sure that it's ready, and then you can interact with the blockchain, but you now have to continuously monitor for any crashes. You have to stay on top of any updates or any forks for the network. And if you do scale beyond a single instance, you might actually run into data inconsistency issues. The second option here is to use the public endpoint. This is actually a service that's provided by Miston Labs right now. So this does address a few of the shortcomings of the first approach. So you don't have to worry about crashes or updates and forks anymore because the Miston team is managing that public node. However, there is a downside, which is because this is an ungated service, essentially, there's no controls for it. It's just open to the public. You may run into some reliability issues, right? There's no guarantees here. So that's one of the downsides of using that. So the third option here is to use Shinami. We provide a more enterprise grade level node service. So there's high reliability. You have support. We open direct channels of communication, Slack channels, Telegram channels with our team. So you always get support if you run into any issues interacting with the blockchain. We also scale with your queries. So as you scale, we're able to scale our service with you and provide consistent responses to your queries. And all those issues with maintenance, those pretty much go away because we will handle that for you. So the services that are offered with the node service is a WebSocket and RPC endpoints. If you're interested, you can go to our website, shinami.com. You can sign up using the referral code KuCoin, and we can get you on board. Okay, so the main topic of the discussion is the Sui gas station. So this allows you to sponsor transactions on behalf of your users. So why would you want to do that? Well, improving your user onboarding and engagement. That's one of the main goals of the gas station. So if we go through sort of a typical onboarding experience for a user, for Sui or any blockchain, let's go over sort of a standard scenario. So a user would have to come, let's say they're interested in interacting with your dApp onto the Sui blockchain. First, they would have to go to some sort of centralized exchange like Coinbase. They'd have to sign up, go through KYC. They'd have to link their bank account. They have to deposit some USD or some currency in there. Then they can buy Sui. Then they have to transfer that Sui out to an external wallet like Ethos wallet or Sui wallet. Then they have to go to your dApp and then connect that wallet in order to interact with the blockchain. So that's quite a bit. That's a lot of friction to onboard a user, and especially for someone who's not Web3 savvy. If you have to do that in mass to a bunch of people, you're going to see a lot of drop off. It's just a lot of friction for users to follow. So what if you could abstract that away? And that's what the gas station does. So if we get to simplify and remove all of those extra steps that a user has to take, you're essentially kind of providing more of a Web 2 experience for users for onboarding. And that most people will know how to use a Web 2 onboarding experience. They're used to it, and you won't see that much of a drop off. So what else can we do? Besides onboarding, we can also incentivize with sponsored transactions. We can incentivize certain behaviors. So, for example, if you want to encourage your users to participate in governance voting, you can sponsor those transactions, so there's not really any cost to them to participate. Other benefits of using the gas station, Shinami does provide tools for tracking all of the transactions that you sponsor. So once you sponsor a transaction, you can view the status. Is it still pending? Is it still waiting to be executed? Has it been executed, or has it expired? There's always some sort of expiration date for all these sponsored transactions. You get to view that either through a dashboard that we provide, or there's also an API that you can tap into to check on the status of all your sponsored transactions. All of the under the hood mechanics of the gas object management, that's all taken care of by Shinami. The only thing currently that you have to supply will have to be the gas budget. So the onus on specifying how much of a gas budget is required for each transaction that you're sponsoring is still left up to the sponsor at this point. We are currently working on automating that and giving you sort of auto gas budgeting. That should be released soon. Okay, so let's go over a simple scenario on how this works at a high level. So let's say an end user comes to your dApp and they want to do some sort of interaction with the blockchain, for example, or in this case, let's say they want to mint an NFT. So they make that request. That request goes to the dApp, which plays the role of the sponsor, right? That dApp wants to cover the expenses of this NFT mint for their user. So they know that what the user wants to do, they can construct that transaction for them. Now, keep in mind, this is not a standard full transaction payload. So this is a gasless transaction, which means it's basically the full transaction data minus the gas context. So that's what we call a gasless transaction payload. So that gets constructed from the dApp. They submit that to Shinami, to our endpoint. We're able to take that payload, we can unpack it, and we can attach from our gas inventory, we attach gas objects for that transaction. We're able to bundle that up back into a full transaction payload, and we sign it. We sign it with the owner of the gas object. So we return those two key pieces of information back to the dApp. The dApp is able to take that information, and the one missing piece left that's needed in order to execute this transaction is one more signature on that full transaction payload from the user. So the dApp is able to get that from the end user. It has all of that information, and it's able to submit that to the Sui blockchain for processing. So those 4 steps, that outline I just went through, you basically just need 2 API endpoints to do that. And we provide 3 here. One is for checking status, but the first one is gas sponsor transaction block. This is the crucial one. This is the one I said where you're as a dApp, you form that gasless transaction payload and you submit it to the gas station that's run by Shinami in order to get all that relevant information, like the full transaction payload and the signatures back. The second one is to get the status. That's fairly straightforward. Like I said, we have 2 ways for you to pull the status of a sponsored transaction. You can either check our dashboard or you can use this API. And the last one is actually from the Sui JSON RPC standard. It's basically just submitting a transaction for execution. Okay, so that's the high level. We'll go into the demo next, but I also just wanted to leave some links up here. For the following demo we'll be doing, everything is already published online. This is a part of a tutorial that we have for how to use sponsored transactions. The code is in our GitHub, so you can check that out. And I've also listed a few of our existing customers that are already using this product if you're interested in taking a look. All right, so let's go through the demo. So for this is actually a live demo. What we'll be doing a very simple transaction, but it sort of just shows what sponsored transactions can do. So for the purposes of this demo, what we're going to be doing, we have 2 addresses here. We'll call this the sender on the left and the recipient on the right. And as you can see, the sender on the left has 1 NFT here, but it has no coins. So there's no gas in this address. The recipient obviously has nothing there. So what we're going to do is we're going to be able to send this NFT from the sender address to the recipient using sponsored transactions. As you can see, there's no gas object, so it wouldn't be able to do it otherwise. And so this is the code. I've taken this code straight from our tutorial. It's in TypeScript. What I've done is the tutorial has a few extra bits of code which I've removed because they're not really relevant. There's only one. The full tutorial has a few other programmable transactions here for examples that you can use. But I've taken that out. We're only going to use one here, which is the transfer. Okay, so we're going to go through sort of step-by-step each piece of this tutorial to show you what's going on under the hood and what's happening during the setup for this sponsored transaction. Okay, so first things first, we need to set up some of the parameters of the entities that are participating, parties that are participating in this transaction. In this case, we have the sender here. So this is the sender address. We'll copy that into the stubbed part. This address, yeah, that's the address. I've taken the liberty of copying the private key. So we need the private key for this address in order to sign that transaction, which is needed at the end. There's two ways of sort of being able to sign it. You can do the private key, or you can do it through a recovery phrase. Both of them work. It's just in order to generate this sort of signer entity. So gas budget, like I said, the sponsor is the one that's responsible for specifying the gas budget for each of the transactions that it's sponsoring. In this case, I've just set it to 5 million missed. The URLs, yes. So there's two services from Shinami that you'll be interacting with. One is the gas station, which provides the sponsorship, and the other one is our node service, which does the execution. So we have the Shinami, make this a little bigger. So this is the Shinami dashboard. In this case, I will be creating a key. We can just call it KuCoin demo. The network we'll be interacting with is Sweet Testnet. And again, the two services we'll be using are node service and gas station. I'll create this fun. So we create the key here. So this is the key that allows us to access each of these services. Paste them each in here. Okay, it's a little bigger. Okay, so we filled out our URLs. All right, the next 3 lines, this is for setting up the signer. Like I said, we need to be able to sign that final transaction from the sender's private key. So this data is already set up here. This is just setting up the signer entity in TypeScript so that we can sign that transaction. Now, all the APIs from Shinami are using JSON RPC. And so for this TypeScript example in our tutorials, we use a library called typed RPC in order to make those calls. So this is just some of the code setup in order to do that. These are the response types from those RPC endpoints. So when you make a query, when you make a request to our gas station or to sponsor a transaction, this is what you get back. So this transaction bytes, this is the final payload that we receive back, the final transaction. The digest is used for tracking, and the signature is, again, the signature of that final transaction from the gas owner. And the sponsored transaction status, this is when we make the request to find out what is the status of this sponsored transaction. These are the 3 options you can get back. This is pending, this is complete, and invalid is like for expired transactions. These are the 2 calls. We have the sponsoring the transaction and getting the status. Okay, so yeah, so this is all the code set up. We got everything done here, nothing else, no other stubbed values we need to fill in. So this bit of code here, this is the programmable transaction that we'll be constructing. Like I said, this is a very simple one. We're just trying to transfer this NFT from this address to this address. So we have the recipient address here. We'll copy that. And we have the object ID, which is this NFT ID. We'll copy that. Object ID. Okay, let's go back. Okay, and so as you can see, this is a very simple programmable transaction, and like I said, it's gasless. So we don't have to specify anything in here about the gas context. We don't have to set the gas payment, any of that stuff. Yeah, okay, so that's a transaction block. So now we're into the execution part of the code. So the code here calls this method to create the gasless transaction block. That gasless transaction block, we need to be able to make that into a payload that we can submit. The way to do that is we build it. Now, remember what I said, this is a gasless transaction block. The terminology I use here is they call it it's a transaction kind. So when it doesn't have that gas context, it's just called a transaction kind versus transaction data, which is the full payload. So in order to build this with just the without any of the gas context, we have to specify only transaction kind to true. So make sure if you're using this, you have to set this flag to true if you're building the gasless bytes. Okay, so once we have the gasless payload bytes, we do need to convert it to a base64 encoded string. That's just the general format of how we pass these payloads into the RPC endpoints. So that's what's done here. Afterwards, we can then submit it to here we're submitting it to the gas station, the Shinami gas station, to get the sponsored response. This is basically sponsoring the transaction. From there, we can check the status. It's just an example how we use the API to check the status of an existing sponsored transaction. In this case, we should expect it to say in flight. Once we have all that, the sponsored response will have the full transaction data, and it'll also have the signature of that transaction data from the gas owner. And the last missing piece here is the signature of that full transaction data from the sender. And so that's what we do here. So we have the signer, and we just pull in that full transaction block here, and we just sign it to get the last signature. Once we have all that information, we can pass it into this execute transaction block, which is basically it's the standard execute transaction call to the Sui blockchain. And so we pass in the full transaction data here, the two signatures, and we should expect the execution status to be successful. So this looks like we have it all set up. All of our stub values are filled in. So let's build this and let's execute it. So you can see the sponsorship status. That was us making that request here. Making the request here so we can see the status. It does say it's in flight, and then at the end it executed it. You see that it's successful. So let's see if this actually worked. So this was the sender, so we can refresh it from the Explorer. And we see that the NFT is gone, and we see the receiver. We refresh it. We see the NFT is now here. And there is now this transaction where we can see all the details of the sponsored transaction. So if you see, let's see, gas fees, right? So remember, we specified 5 million missed for the gas budget. You see that specified here. And yeah, so we were able to successfully send this NFT in a sponsored transaction live on Testnet. These addresses have no gas. We were able to sponsor it through Shinami. And yeah, so that concludes the demo. We have about 10 minutes left, I think. So I will open it up to any questions that anybody has.
All right. Thank you, James. That is really cool. Yeah. So yeah, I think this is going to be very helpful to a lot of teams that are going to be building apps for either the hackathon or for Sway in general, right? Okay. Is there any way for like a team to try it out, if they want to test it out on like Testnet?
Yes. So like I said, sign up with our website, use that referral code, sweet KuCoin, and we can get you onboarded. For Testnet, we currently do offer a gas station where we for the fund, basically each account that you sign up for, each team requires funds in order to do this, right? To be able to sponsor transactions, right, you need to have some sort of fund. For Testnet, we offer a basically 10 Sui to play with every single day, so we automatically top that up. So for Testnet, if you want to play around with it, sign up. We'll get you onboarded. You can play with it. You pretty much have 10 Sui to sponsor away every single day, and we top that up every single day.
Great. All right, great. So I currently don't see any questions. So I think we'll just like wrap up. Okay. And I think so the link for this workshop will be available on the Sway Network YouTube channel. Okay. And also I think we'll also add like a link to the slides into the video description afterwards.
Yep.
So yeah,
So we can put that
that's it.
in the video. I can also drop this off, post this the link to the slides in the Telegram channel wherever people are connected.
Sure. And I think like if you have questions later on, like if you missed our live session, you can ask in our Slack or in our Telegram groups. All right, thank you,
Okay.
James.
Thanks everyone.
All right, bye bye.
Bye.